Okay. I wanted to do this problem for IUPAC naming because you're going to have to use systemic nomenclature. Systemic nomenclature isn't always super intuitive, so I really thought it would be a really good practice video. So go ahead and hit pause to see if you can name this compound using IUPAC systemic naming. Otherwise, I'm going to go ahead and get started. Okay, so I'm going to zoom in because this compound's a little bit bigger and I just want to make sure I write clearly on what I'm doing. So we're going to do the same thing we always do, and that's going to be trying to figure out what our longest parent chain is going to be. So better to just start here, just guess. So if I go for, all right, I have a split here, so let's go 5, 6, there's 7. If we keep going straight, 5, 6, 7. Okay, so I have a decision to make here. I need to go one way versus the other. If I go the pink way, I would have 1, 2, 3, 4, 5 substituents. So how many substituents would I have with the blue? Let's see. That's a nice blue. Anyway, I would have 1, 2, 3, and then 4. Okay, so because of the fact the pink way has more substituents, that's going to be the way I need to number this, because I want my longest possible chain, but I also want the most substituents in my structure. So let me go ahead and get rid of all of the blue, so we know what we're focusing on. So all of these right here. Okay, so there's another one. So I want to number this way. Well, I know that that's my longest carbon chain. I don't know that's how I want to number it until I do my substituents. Well, I can actually look at this and see that this is symmetrical. So I know it's not going to matter which way I do left to right or right to left. I can show you that because it will be the exact same answer. So in this case, if I go from left to right, I would have a 2, 3, 4, 5, 6. If I go the other way, I'm still going to have a 2, 3, 4, 5, and 6. So in this case, it truly doesn't matter which way you number this, left to right, right to left. You should get the same answer. And in fact, that's probably a good exercise for you guys to try. If you want to look at left versus right, the answer should be the same. Okay, so now I know what my parent chain is, so I'm going to do my circle here. I can see that I have 4 things touching my circle, so I have 4 substituents. But before we get that far, let's remind ourselves that 7 carbons is going to have a parent chain of heptane because of the fact it is 7 carbons, and also it is an alkane. So that ane ending is referring to that functional group. Hept is to the number of carbons. All right, now we're going to look at our substituents. So I can see very, very clearly that I have a lot of methyl groups, right? I have 1 carbon coming off the 2, 3, 5, and the 6. So instead of writing those out, I'm going to go ahead and combine them into what they would be in the name. So my substituents, I'm going to have a 2, 3, 5, 6. So those numbers are where they are located. And then because I have 4, it would be a tetramethyl. So that's how I would name 4 methyl groups in my compound. Now we're going to address this monstrosity, right? Okay, I don't have an obvious common name like isopropyl, sec-butyl, tert-butyl. So I'm going to need to use the systemic naming. All right. With our systemic naming, we're going to treat it like a mini compound. So we're going to ignore the parent chain and only focus on this substituent right here. So if I'm pretending it's its own compound, we're going to do the same steps we would always do, and that is number the longest chain. Luckily, this one is a singular linear substituent, so it's just going to be 1, 2, 3, 4, 5. That is my longest chain. Could I have numbered it the other way? Yes, because it would still give me 3 with where we are bonded to the parent. All right, so that's the first step. So I know that the mini parent, if you will, of this substituent should have a pent prefix because there's 5 carbons, but it's still a substituent. So be careful here. It is still a substituent. I still have to add that YL to indicate that, right? So this is still going to be a pentyl. Now, if I look at my mini compound, I don't have anything other than my parent chain coming off of it, so I don't have to worry about any substituents coming off of my substituent. Ooh, that's like Inception IUPAC version. That's weird. But I do have to say where the parent chain is attached here. And so we can clearly see that's the 3rd carbon. Where am I going to write that? Well, I'm going to write that right after the numerical prefix and before that ill. So this is now going to become a pent 3 ill. Oh, sorry, I said pent. It should be pentan. Excuse me. Let me try that again. So I should have pentan, where I would have, instead of the E, that's where the ill comes in. Excuse me about that. And then I would say pentan 3 ill. All right, that would be the name of the substituent. So that's how I named this part. And I still have to say where it is located on my actual parent chain. Well, we can see that it is located on the 4th carbon. So the way I would write that is I would say this substituent is located on the 4th carbon. And then everything we just did, we would just put in parentheses. And that's why it's called parenthetical. So pentan 3 ill. All right. Okay. So again, if you're going to name the parent chain of your substituent, instead of saying pentane, you drop that E and you add YL. Okay, I just want to review that since I did have that slightly confused. All right, now we're ready for the full name of this huge structure. So what we are going to write is, all right, I need to look at my alphabetizing. I don't look at the numerical prefix, so I have an M versus a P. So A, B, C, D, F, G, H, I, J, K, L, M, N, O, P. Okay, so M goes first. Yes, I just sang my alphabet because I don't know that off the top of my head. All right, I'm going to start down here because it's going to be a big one. So 2, 3, 5, 6, tetramethyl. And then I'm going to have a number, so I do a dash, 4 dash, pentan 3, ooh, I forgot my dash, 3 ill heptane. All one big, beautiful word. So that would be the IUPAC name when I'm starting to look at systemic naming.